Hi, this class is to talk about the steps to test the hypothesis of a population mean when you know the population standard deviation. Okay, so here's the first approach, which is the critical value approach, and here's the steps. First step is develop the null and alternative hypothesis. Second step is determine if it's a lower upper two-tail test. Third step is specify the level of significance. If it is lower tail, you use the alpha level as it is. If it is upper tail, you do this, 1 minus the alpha level. So if the alpha level is 0.01, then you do 1 minus 0.01, which is 0.99. If it is two-tail, you do alpha divided by 2 and use as it is. Step 2, 3.1, use as it is. And step 3.2, subtract 1 minus the alpha level divided by 2. So you're going to have two values for the alpha because it's a two-tail test. You're going to have one in each tail. You find the z critical associated with the level of significance here. So you got two alphas, then you find the z. So how you find the z? Use this formula, equal norm S inverse, and then you enter your alpha or the alpha level divided by 2 as specified in this step. Collect the sample data and compute the value of the test statistic like I showed you, and I'm gonna show you how to do that in Excel. Compare the test statistic. So we're comparing if the resulting z from the sample data is higher or smaller than the z critical. That's the reason it's called critical, because it's going to be critical to compare with our z found from our sample. Similar to the problem I worked with you here in the previous slide, I show you how to get the z-score for this problem. Then you compare that z-score with a z-critical that you find using the level of significance and determining if it is lower upper two-tail test. Okay, so I'm going to show you how to do that. But these are the steps. The test statistic z comes from the standard normal probability distribution. You can use Excel to find the z like I showed you in the previous slide. The value of the test statistic that establishes the boundary for the rejection region is called the critical value for the test. Let me show you what this means. So let me come here. Where is okay? This one. So let me show you the steps and then I try to understand. We don't need a problem. Let's say we have any problem. The first step would be step 1, come up with the null and alternative hypothesis. You have to read the problem to come up with the null and alternative. Then step number 2, you determine if it's an upper tail test, a lower tail test, or a two-tail test. How can you know? The hypothesis, remember? If the hypothesis is this way, then you have a lower tail test. If the null hypothesis is like this, then you have an upper tail test. And if it's different, if it's equal, then you have a two-tail test. You can watch the video about hypothesis development if you don't remember. But that's the first two steps. Come up with the alternatives and determining the rejection, the region, upper, lower, two-tail. And then step number 3 is to come up with the alpha. Okay, and follow the rules on step number 3. And in step number 4, you have to find the z associated with this alpha. Remember, you learned how to do that in chapter 8. So you can do norm S inverse, and then you put the alpha, let's say 0.01, and then you get, I think that is 2.54. I think that's 2.54 or 56. The z associated with this level. And then step number 5, so you have a z critical. This is a z critical. So if you draw the distribution, you can like draw this is the critical point of rejection. This is the rejection region. Okay. Now, one of almost the last steps is compute the z statistic. Remember how to do that? You get the sample mean, subtract from the hypothesized mean. This is what you have in your hypothesis. So let's wait, come on, yeah. And then you divide it by the standard deviation of the sample mean. So let's say you get a z-score of 3.10. Okay, so this 3.10 will be higher than 2.56. That's the rejection region. In this case, you reject the null hypothesis. Okay, if the z-score is smaller than that, let's say z-score is 1.56, it is here. Here is not the rejection region. So you fail to reject the null hypothesis. Okay, so these are the steps, and let's see if I can have a problem to show you how to do that in a problem. Let's use the same problem we had before. Yeah, I could have done that, but let's do it now. Okay, so remember this problem is the hilltop claim. Let's say they claim that they have, so step number 1, the null, that is higher or equal than 3. The alternative is that this is smaller than 3. Step number 2 is, oh, I'm sorry. So step number 2, so these are the null and alternative, they come from the problem. So step number 2 is determine if it's upper, lower, or which tail. So because it says that this is smaller, it's a lower tail test. Okay. Step number 3, alpha. Alpha is given in the problem. Let's take a look at the problem. Problem says alpha equal level of significance 0.01 equal to 0.01, right? So my slides say for the critical value approach, if lower tail, use alpha as it is. So I don't do anything, I use as it is. Step number 4, I find the z using norm.s inverse 0.01. I can use Excel to do that very quickly. So let's say equal norm dot s inverse. Why is number inverse? Okay, probability is point. Because again, look, because it's a lower tail test, I use as it is. So it's negative 2.32. Okay, so let me go back here. So my z critical, it's my z critical. So I can draw, oops, I don't need to draw here. Let's use here, negative 2.32. That's my rejection region. Okay. Now step 5, I compute the z based on our sample, which is 2.92 in the problem, minus 3 in the hypothesis, divided by 0.18, the population standard deviation, divided by 36 cans. This is equal to negative 2.67. So now I compare, this is my z statistic, Okay, Now I compare where this number is in this distribution. Is right here, negative, right? Negative 2.67 has to be smaller than, has to be less than negative 2.32. So it is in the rejection region. Yes, it is. So my conclusion is reject the null. Basically, if the z-statistic in this case, in the lower case, is smaller than the z-critical, I reject null. Okay? If it is upper tail, let me see if I can do it here. If it is upper tail test, the rejection region is here. If it is an upper tail test and the z-statistic is higher than the z-critical, then I reject. This is reject. I reject the null. And if it is two-tail test, I have two regions. And if the z-statistic, this guy here, if this guy here is here or here, then I reject the null. Okay? So this is the critical region approach.